Students, this is the preview notes for the introduction to area. Remember that you need, please put your name on this, the date and time that you're watching this video. Remember to get a parent, teacher, or guardian sign off. Let's start with the review problem. It says, a circle has an area of 62.83 meters squared. How many times must that circle roll in order to cover a distance of 1 kilometer? I'd like you to try to do this on your own. I'll give you 3 minutes, and then we'll check. Okay, let's see what you have figured out so far. So first we want to try to draw this. We have a wheel or a circle, and so we're going to draw that circle, and we know that its area is 62.83 meters squared. That's the area. We're asked how many times must the circle roll. So we're being asked about the number of rolls to cover a distance of 1 kilometer. Okay, now we ask ourselves, what can we do? Even if you're not quite sure how to do all this, let's do something super simple. You can at least write the equation for area, because we're talking about area, which is apple pie is really, really good. And we see here that those can be made equivalent, so we're going to go 62.83 equals pi r squared. We're going to solve by dividing by pi. So I have 62.83 dividing by pi, and then we're going to square root. And we get 4.5 basically. So we divide by pi, and then we square root, and we have the radius equals 4.5. Watch your units, meters. Now I want to talk about roll, and something that rolls technically means circumference. So we're going to do circumference equals d pi. And if our radius is 4.5, our diameter is 9 pi. 9 times pi gives us 28.3 meters. Now, this is where it gets interesting because you have to watch your units here. This is 28.3 meters for every roll, but we're going a kilometer. So you need to know that prefix kilometer means 1,000. So we have 1,000 meters divided by the 28.3. And we get approximately 35.3 rolls. You analyze your work compared to mine. See what you did correct. If you did something different, but still got the same answer, great. If you got a different answer, most likely it's because you didn't account for the units. Let's go ahead and dive into what we're learning today. Today we're dealing with, we're going to introduce our final unit on area and solids. We're going to start with some basic area equations. Area of a parallelogram, a rhombus, a rectangle, a square, a trapezoid, a kite. We're going to talk about base and height and the concept of a diagonal. So we'll do the equations for a quad family tree. Quad family tree. Area of a rectangle. Of course, you know area of a rectangle to be length times width. So area equals length times width. Now, because there is a right angle here, we could also call the length and width the base and the height. So another way of saying area of a rectangle would be area equals base times height. Whenever you see that word height, make a little note there. There is always a right angle. Wherever you see that word height, there is always, 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 always a right angle. Now for a square, because all the sides are equal, we'll just call it side. So of course the area here is just that side squared. You could say length times width. Technically it's a rectangle, it's a rectangle as well, but they're the same, so we just say side squared. I want you to do a little experiment here with me. I want you to drop down a straight line here, from here to here, drop down a straight line. I'd like you to shade this leftover triangle. Now I'd like you to shift this leftover triangle over here. Bring it around. Shade it. I want you to see that if we just slice off that triangle there and shift it, it creates the same area. And you should see that that parallelogram, the actual area, is simply a rectangle. So we have base times height for a rectangle, and that is true also of a parallelogram. Just got to remember, in a parallelogram, that word height always is a straight line at a right angle. That's going to be your height. Or it could even be on the outside at a right angle. That's your height. Your base is going to be this length right here. So area of a parallelogram, area equals the length of the base times height as well. A rhombus and a kite, they have something in common. That's why their equation is in common. A rhombus and a kite both have perpendicular diagonals. So let's draw them in. They have diagonals that meet at a right angle. Perpendicular diagonals. Now, whenever you have perpendicular diagonals, you can use this equation for area. Area equals, of a rhombus, one diagonal times the other diagonal over 2. One diagonal times the other diagonal over 2. On the right, area equals one diagonal times the other diagonal over 2. That's for a kite and a rhombus. You can use the diagonals, the product of the diagonals over 2, because they have perpendicular diagonals. Now, a trapezoid is kind of like a parallelogram, but the problem is we have two different bases. So a parallelogram, let me just remind you, a parallelogram is the length of the base, of which they're the same, times the height, of which you have a right angle. But in a trapezoid, we have two different bases. We'll call this one base 1 and base 2. The bases are always the parallel sides. So to do a trapezoid, there's something we have to account for with their bases. So to get the base, we actually have to average these. So it's going to be base plus base over 2 times your height. And remember, height always creates a right angle. So you drop it straight up or straight down, creates a right angle. That would be your height. So that would be the area of a trapezoid. You average the bases times the height. In this trapezoid on the left, these would be our parallel sides, which make them the bases. So base, base. Really doesn't matter which one's base 1 and base 2. Our height creates a right angle, so sometimes the height is on the edge. Otherwise, you have to drop it and make it a right angle. So again, the area equation of a trapezoid is area equals, average the bases, base plus base over 2, base 1 plus base 2 over 2, times that height. Now take just a few seconds, glance over these two pages. Come over to this page, and when you're ready, I want you to try to write out these area equations for all of these from memory. Try to fold your packet back so you can't see any of them. So you have these on there and this. So fold your packet on the left back so you're only looking at this. Do a little test. See if you can't fill these out from memory. I'm going to set the timer for 1 minute. Ready? Go. Try to fill this out from memory. Okay, let's see how you did. Parallelogram is going to be area equals base times height. That's height straight up at a right angle. Base would be either of the parallel sides right there, base times height. A rhombus, area is diagonal times diagonal over 2. Rectangle, length times width, or base times height. Square is just side squared. Trapezoid, average the bases times the height. Isosceles, kite is diagonal times diagonal over 2. Let's take a shot and do a couple problems together. It says finger track read, highlight and underline keywords. We have a rhombus has a side length of 5 feet. The longer diagonal of the rhombus is 8 feet. Find the area of the rhombus. Okay, let's draw what we have. First off, we have a rhombus, which is basically a square pushed on its side. We're doing draw, label, list, cross out. That's a rhombus. All sides are equal. I'm going to draw on the diagonals. We have a right angle there. We have a side length of 5 feet, so we're 5 feet all the way around. Cross that out. The longer diagonal of the rhombus is 8 feet. So the longer one, this whole thing is 8 feet, of which that means that that's 4 feet and 4 feet because they bisect each other. And we want the area. So let's write our equation out for area. Area of a rhombus equals diagonal times diagonal over 2. Let's analyze what we have here. What can we do? We just wrote the equation out. So we have one diagonal. We need, obviously, the other diagonal, which would be right here. Problem is we don't have it. So rather than focus on what we don't have, let's take a look at what we do have. So you have a triangle here. Let's pull this triangle out and see what we can do with that. There's a right angle there. Remember, right angles means you have the key to the universe. That's 4 feet. That's 5. We need this blue piece, obviously, because once we get it, we can get our whole diagonal. We'll call it X. So we're going to do two sides of a right triangle. We write our equation out, which is Pythagorean theorem, leg squared plus leg squared equals hypo squared. So circle plug chug, x squared plus 4 squared equals hypo squared. We solve here, we're going to end up with x squared equals 5 squared minus 4 squared. And we're going to square root both sides. So x equals, that's going to be 25 minus 16 square root, which is the square root of 9, which is 3. So we get this is 3, which is 3, which means now we can circle plug chug. Area equals diagonal. We trace it. The whole diagonal is 6 times the other diagonal, which we already have, 8 over 2. Key to multiplying is not multiplying, so I'm going to reduce. You could either reduce the 6 or the 8. It doesn't matter. I'm going to reduce the 6. So 2 goes into 6 3 times. 3 times 8, we have 24. Let's check for units. Our units is feet squared. So take a moment and ask yourself, how did we start this problem? What was the middle? And how did we end? Let's try another one. says the area of a trapezoid is 160 meters squared. The bases are 12 meters and 20 meters, respectively. Find the height of the trapezoid. Keywords. We have the area of a trapezoid. We have the bases. We want the height. So I'm going to start by draw, label, list, cross out. So I draw a trapezoid. And I already have the area, so underneath I'm going to write area equals 160 meters squared. Area is 160 meters squared. The bases are 12 and 20 meters. We want to find the height, which we don't know. We draw, there's our height, that's what we don't know. So we've gone draw, label, list, cross out. Now we're going to squeeze the sponge and ask, well, what can we do here? We have a trapezoid. We can at least write the equation out, which is area equals average of the bases times height. You can at least do that. Remember equations, we have two sides with an equal sign. So now let's see if we can circle, plug, chug and solve for our unknown. We have our area, it's 160. We have both our bases, 12 plus 20 over 2 times, the only thing we don't have is our height here. So just wrap up the math. This is 160. That equals 32 over 2 times the height. That's 160. That's going to be 16 times the height. Divide both sides by 16. And our height is 10. Oh, don't forget units, meters. All right, these two pages I want you to try on your own. I set the timer for 5 minutes, and then we'll go over them. So take a shot at these two on your own. In 5 minutes, attempt. If you finish early, just scroll to the end of the 5-minute timer, and then we'll go over the answers. Please do this on your own. Just don't copy. Do this on your own, and check your work. Okay, let's see how you did here. Taking a look at this first one, on the left, it says the perimeter of a rectangle is 40 feet, or 40 centimeters, excuse me. That's perimeter. The length of the rectangle is 3 times longer than its width. Find the area. So let's do draw, label, list, cross out. Let's do the simple. Perimeter is 40, so I'm going to write P equals 40 centimeters. Cross it out. The length of the rectangle, so we're going to draw a picture. The length is 3 times longer than the width. So here is the width, and the length is 3 times longer than the width. That's 3 times, not 3 more than, so it's a times. We want to find the area, so we're going to write the area equation out for, which is length times width. So let's see what we can do here. We have perimeter. Perimeter equals 40. And we also know we can do this for perimeter. If we just put it here and walk it around, we see our perimeter is going to be W plus 3W plus W plus 3W. So I'm going to do this. I'm going to make 40 equals W plus 3W plus W plus 3W. Collect like terms. That's 40 equals, that's 4 and 8, 8W. We divide, and we figure out, divide by 8. And W equals 5, which makes the length to be 15. We want to find area, which is length times the width. And our length here is 15 times our width, which is 5. 5 times 15 is 75. We check for units, centimeters squared. Let's check this one. This one's called a composite shape. So there's a couple ways you can look at this. Either you can look at this as 2 different rectangles. You can go like this and see it as 2 different rectangles. And there's a couple ways you could have divvied that up. Or you could have seen it as one giant rectangle. In which you find what we call the negative space, and then you just bite out this negative space. So that's the couple ways you can look at this. Both are going to get you the same answer. I'll show you both. Here we just do length times width, so that's 6, and then this is 2. And here the length, that's 3. Now there's a little trick here. You aren't actually given that length. Be really, really careful there. Don't just assume things. Let's look at what we do have. The whole thing's 5. And this little piece is 2. So that means our squiggle here is 3. So we find the area, which is length times width, so that's going to be 6 times 2, and the area here is 3 times 3. So it's 12 plus 9, which is 21, and check for units, feet squared. The other way we could have looked at this is we could have gone the whole purple, which is 6 times 5, which is 30, and subtracted this negative space, and this is 3 here, and this right here, if this is 3 here, the whole thing's 6, that's 3 times 3, so we're going to minus 9 for the orange, again, which is 21 feet squared.